Okay, so let's go to the green design strategies, which are very important and very critical when you keep in mind retrofitting. Okay, we'll do it in these 4 points. First, we talk about the site, what is important in the site, then the building, utilities, meaning electricity and water, and then finally we go to the materials. So let's look at the site. Even before you design a building, think that there are many things that go around the building. There's the sun, maybe there are mountains, there's a level of rain, there may be water bodies, etc., etc. There might even be groundwater. In other words, analyze the site. And then, what's the most important thing in the site? Especially in the Philippines, there are things in the Philippines which we have to contend with. First is sun. We have a lot of sun. What does it equate to? We may have a lot of heat, but we also have a lot of natural light during the day. We have natural wind. So look at this. Solar orientation for the site. This is the story of the good, the bad, and the ugly. Let's say north is there. This must be south, west, and east, right? The sun rises on the east, correct? And then it sets on the west, correct? In the Philippines, right? Well, actually the whole world, anywhere in the world else, okay? Now, in the Philippines, we are slightly above the equator. What does it mean? This is green architecture. You have to know where that sun is passing through. It moves from east to west a little bit on the southern side. Take note, southern side. So given that, already, building orientation is important. Good. Why? You have a very small side facing east-west, and you have most of your windows facing north-south. Okay? Square? Okay, 50%. 50-50? 50% is on the east-west, and 50-50 is on the north-south. But all windows are facing either east or west somehow. The ugly, no? Baliktad to. Almost all your windows face east and west. It would be okay if this was a sauna bath, no? This you should have the hot sun to heat you up, no? But if it was for living and you want to cool yourself, I don't think this is a good idea. Okay? So solar orientation is the very first important thing to know. When you're going to design a building, make sure you orient your building in the right way. Because if not, retrofitting it will become a major headache. Example, this is very near here. This is in Argao. In Argao, we were given the task of doing the master plan for the Philippine Science High School campus. North is up. Look at all the buildings. This is a green campus. Simple orientation of buildings. All the classroom windows face north. Solid walls on the east and west. Wind. We all know that in the Philippines we have the Amihan and Bagat. The wind passes from the northeast and southwest. However, this may change depending on the exact location of your building. Mountains could affect it, or if you're very, very near a big body of water, the wind pattern is different. The wind from the day comes from the sea, and at night it comes from the land. So be sensitive to that. Utilize it and maximize it and use it in your building. This is a bed and breakfast done in Pawai, Ilocos Norte. It's very hot. This is the building. North is up. Amihan and Abagat moves there. What we did is we were able to configure the building in such a way that we were able to catch this breeze here, pass it through the dining space, and go up. And the other way around during the cooler days. If I stand here, looking there, this is what you see. And that is how the dining space is al fresco. Now let me share with you how green architects work. I designed this building and I didn't tell the owner that I was actually implementing green architecture. 2 years after it was built, I passed by and stayed there for a while. He told me, "Hey Mike, how come people always hang out here? They say even if it's so hot in Hawaii, it's cool here." I said, I didn't tell you this before, but actually I started explaining to him this diagram. He said, "Wow, galing, no?" You know, sometimes as green architects, sometimes we're afraid to tell the owners right away that we're doing it because it may not work, no? So sometimes it's experimental, you know? Because it's an assumption, no? An assumption. No? The wind is supposed to pass northeast and southwest, no? Right, okay. I used the theory, I implemented it, and hoped for the best. It was good, so now I went back 2 years later and said, telling that story, and now he brags to everybody, you know, my building is green, you know. All of a sudden, no? Buti na lang it worked. If not, I wouldn't have showed this slide. Now, we go to the building. There is a function for the building, and this is important for retrofitting. In a site, we have a variable exterior environment. The environment outside could be hot, could be cold, could be wet. And yet, we want to achieve inside a stable interior environment. So the function of the building envelope is that barrier between the outside variable environment and the inside stable environment we want to create. Okay? Now, so that's the building form. Barrier between inside and out. Now the building fabric is the moderator of the climate. So, if you want to maintain a stable environment, we can either let light in or block light. We can let breeze in or block breeze. It depends. So these are the functions, no? Since our objective is to create a stable interior environment as against a variable exterior environment, we need the building fabric to moderate the movement of climate, either getting the climate in if it is good, or blocking the climate out if it is not good for that stable interior environment. Going back to the light, no? For example, this is 3D. No? If this is the north, meaning west is here and east is there, when you have windows on the east and west, aside from minimizing it, then you can use sunblocks, no? Sunbuckles. On the south, you can have normal windows, but in the Philippines, make sure you have overhangs or medyo agaw. Why? Because there's a little bit of sunlight directly hitting the southern facade of any building. But take note, in the Philippines, if you have a window facing north, you can afford to have a floor-to-ceiling, wall-to-wall window in which you can have all the natural light coming in, natural light, not direct sunlight, natural light, and at the same time, you can have all the breeze coming in. Okay? It's interesting thing, because if you let all the light come in during the day, you don't need to turn on your electrical lights during the day. Now we go to water. Let us go slowly over this thing because it will come out to have some interesting results. Cycle of water. We get water either from the rain or from the equivalent of Nawasa here. I don't know what the equivalent of Nawasa here is. We use that potable water to shower or to wash our hands. We can use that water to flush the toilets or to water the garden, right? After you flush your toilet, that water goes into the septic tank, usually 2 or 3 chambers. What if after the 3rd chamber of the septic tank, you treat that water and you use it again to flush your toilets? You know what you created? You've created a closed system. In other words, you flush your toilet, it goes to the septic tank, and then after that, it gets treated. There are natural ways like reed bed. If you want more buildings like this, they require an STP, no? You use that water again, this STP. Normally what happens is just dump it into the storm drain of the municipality or the city. Why not use that same water to flush your toilet again? You have a closed cycle. If you can implement that, you can imagine how much fresh water savings you're actually going to have through the whole lifetime of that building.